Okay, so let's have a look here. What I want to do today, here's kind of the goal. We're going to do two things. One of them I won't even mention yet, but one of them is I want to go through a couple examples solving quadratic equations where we're going to start to be a little more selective about strategies, right? So we're going to look at these and we're going to see if we can start to maybe come up with a system. JJ, you with us here?
Yes.
Okay, we're going to come up with a system for doing these things. You guys gave me two suggestions for this one, and they both were good. When a is equal to 1, completing the square is pretty simple, right? So one thing we could do with this, and let's go ahead and just get a little practice with that. If I'm going to complete the square, solve this by completing the square, Cheyenne, what's the first thing I've got to do?
Well, you see, you gotta divide? No.
What am I going to do? Okay, but before I do that, I've got to do...
Oh, wait, subtract 73.
Subtract 73, good. Okay, and then that sets us up to complete the square. Now we got to fill in some blanks. Dominic, what number is going to go there? No, -8. There we go. Half of b, right? So we know we're going to get x minus 8 quantity squared equals some number, but that's going to allow us to solve for x by isolating x pretty easily, but we got to know what goes over here. Lauren, what am I going to add to both sides of the equation to make that perfect square? Say it again. 4. -8 squared, right? -8 squared is 64. Okay, and then what about on the other side? What do we end up with, Juliana, what do we end up with over here then, the number on the other side?
9.
-9, good. Okay, so we completed the square, that was useful. Now we've got this in a form where I can simply isolate x. What are the two steps going to be, Robert? What am I going to do first?
You're gonna square root.
Good, then?
And then you're gonna
Add 8, good. Okay, so we're going to end up then with x minus 8 equals, what happens when I square root this side? I got to get a plus or minus in there, right? What's the square root, Jeremy, of -9?
3.
Good, plus or minus 3, and then the negative becomes an I, right? And then last step you told me was add 8, so we end up with x equals 8. We're going to put that in front of the plus or minus, right? 8 plus or minus 3i. Okay, that worked great. No problem. What's the other method? Well, you mentioned quadratic formula. We know the song now, so let's try one of those. What's A?
1.
What's B? What's C? Okay, so then all we have to do, quadratic formula is, all it is simplification. You already have the formula set up, you're just going to plug it up, right? You're just going to plug stuff into the quadratic formula. Now what is that again? X equals...
-3 plus or minus a square, and it should be c. No, b squared.
B squared minus 4ac.
All over 2.
Good, divided by 2a. So we're just going to plug stuff in there, right? So we end up with negative b is what? Positive 16. Okay, Tony, what am I going to get for what's inside here? What's b squared going to be?
Minus 16 squared.
Yeah, what is that? Anybody remember? Anybody know? The squares are good to know. I might make you guys learn it.
No, please don't.
256. Minus 4 times 1, which I don't need to write, times 73. Good. All divided by, what am I going to get on the bottom? 2. 2 times 1 is 2. Good. Okay, so then we just have to simplify that, right? So we end up with 16 plus or minus the square root of 256 minus 4 times 73. Well, what's, okay, 4 times 73, let's break that into parts. What's 4 times 70? 280, good. And then 4 times 3, so 280 plus 12? 292, so we get 256 minus 292, which is, what is that, 36? Negative 36? all divided by 2. So let's split that apart, right? We've got the plus or minus, we got 2 terms on the top. Let's just write that as 16 over 2 plus or minus, what's the square root of negative 36? 6i. Okay, we're going to get an I because of the negative. And then if I reduce both those fractions, don't I just get 8 plus or minus 3i, just like I got up there? Okay, which one's easier? I mean, I don't know. I mean, I honestly, I kind of prefer completing the square, but they're both pretty equal, right? Pretty equal. But what happens, so in this case, I would say if the coefficient of x squared, if a is equal to 1, take your pick. You could either complete the square or use the quadratic formula. It doesn't really matter. They're both about equally easy. Okay, Sean, get that phone away, please. I got x-ray vision. I can see back there. What about this guy here? What's going on with this one? What do I need to do before I can solve?
Subtract x squared.
Okay, you have to put it in what form?
Standard.
Standard form. Good, I got to subtract x squared from both sides. So that's going to give me how many x squared?
4x squared.
Okay, so with this one now, let's think ahead. Let's think think what our path is going to be like if we complete the square. What are the things I'm going to have to do to put this into the form to complete the square? Add 7, good. And then divide by 4. Okay, that's where things could get a little bit ugly, right? When we have to divide both sides of the equation by a number, I'm going to get fractions introduced. Completing the square gets a little tougher with those, right? This is where I'd say the balance tilts towards quadratic formula, because the quadratic formula is no harder if a is equal to 4 or 1. It really makes no difference, right? But completing the square gets a lot, well, I wouldn't say a lot, but it gets enough more difficult that it wouldn't make sense to do it if a is equal to something other than 1, right? So let's just say our system then is going to be if a does not equal 1, we're always just going to use the quadratic formula, right? So what's that going to give us then? We're going to get x equals negative b, right? So what's that?
4 and 4.
You know, I'm going to write it out real quick. Plus. So we get negative b would be positive 4, right? Plus or minus the square root, what's b squared? 16. Minus 4 times negative 7, good. All divided by 2 times 4, which would be 8. Okay. Here's something you can always do also then. So look inside the radical here. I've got a negative 4 times negative 7. What happens if I have an even number of negatives being multiplied? It's going to become positive, right? So one thing we could do is just do that, right? So we know right away we're getting something positive. All right, so now we have to just simplify this thing. So 4 plus or minus the square root of 16 plus, let's see, what would be the easiest way to do this? Well, what's 4 times 7? 28 times 4. When you multiply by 4, it's pretty easy. Double it and then double again.
92.
No. What's 28 doubled? Doubled? 112. Right, good. So we get 16 plus 112. What is that?
1.
Good. And that's all going to be over 8, right? So let's go ahead and split this up into separate parts. So then we've got to simplify that radical. We can do that. So we've got 128. Have you noticed that it seems to be like if we've got an even number, what's probably the first thing I should factor I'm going to divide out? 2. Why not just take a 2? Right? So I know 2 goes into 128 because it's even. So I get 2, and then what's left over? What's half of 128? Okay, 64, right? Right? Then that's even, so I can take a 2 out. What's left over?
32.
That's even, so I can take a 2 out. What's left? And 16, that's a perfect square. So we could make that one into what? 4 and 4. We don't really have to go any less than that. So now what do we get? We got couples of 2s and 4s, and we've got a single 2, right? So then what's that mean we're gonna get? We get 1/2 from that first fraction, plus or minus. What's the square root of 128 gonna become then?
8 radical 2.
Okay, good. We're gonna have the product of all of the couples goes out front, so 2 times 4. And then we're stuck with only one single inside, and that's all divided by 8. What happens to the 8s? They cancel out. Good, so we end up with 1/2 plus or minus the square root of 2. How many solutions did we get?
2.
2. A plus, one for the plus, one for the minus. How many solutions did we get there?
2.
2. One for the plus, one for the minus. Okay, can you tell me, if we're just looking at the quadratic formula, well, let's do one more, actually. Yeah, one more. I forgot about this one. Okay, what about this guy? What's A, B, and C?
3, negative
3, negative 15, 30. Those are big values of A, B, and C, right? When we start multiplying those together and squaring them, we're gonna get big numbers. Is there a better approach to this one?
30. Divide by 3.
Oh, yeah, good. We could divide by 3 or factor out of 3, however you want to think about it. One way we could do this is if we factor out of 3 from the left side, what's left over?
X squared minus 15x.
Minus, I heard it, 5x, right? 3 times 5 is 15 plus 10. And then I could just divide each side by 3, right, to get rid of that, because I've got a 0 on this side. And then another way, and this is the way we've kind of talked about it, I think it's a little bit easier. Okay, we can see here that the greatest common factor is going to be 3, and so why not just divide each side by 3? If I'm going to divide each side by 3, it's easier just to divide each term on the left by 3. Either way, we're going to get the same thing. We end up with what? X squared, 15 over 3 is 5, 30 over 3 is 10, right? And then from there, it's pretty simple, right? Now we can just do the quadratic formula or complete the square. We got A equal to 1, so either one's a good choice, right? But it was really important for us to divide both sides by 3 because it gave us a much easier problem to do, right? Okay, here's my next question for you. We did 2 examples. On the first one, if you look back at our solutions, the first one had i's, right? The second one did not. Second one, we just got regular numbers. You got a square root, but no i's, right? Could you make a prediction for me based on the quadratic formula? How would you first know if you're going to have i's in your answer or not?
If you have a negative radical.
Okay, so we know i's pop into the situation if we have a negative number inside the radical, right? So the only part that's in the radical is this part right here, right? The number that we calculate when we simplify b squared minus 4ac, if that's a negative number, are we going to have i's?
Yes.
We are, right? If that's negative, we know that we're going to have imaginary numbers because we're going to end up with a negative inside the radical. If that number that we calculate inside the radical is positive, are we going to have i's? No. Then we're not going to have i's, are we?
So pretty much you can determine if it's going to be negative if both the A and C are positive?
Well, that's, okay, that's one, if A and C are both positive, then what happens? If A and C are positive, we're going to get a positive number, b squared is going to be positive, minus a positive number. What are the possible outcomes if we have a positive number minus a positive number? What's one thing that could happen? We
Negative.
could get a negative result. That would be i's, right? What's another thing that could happen?
Positive.
We could get positive, no i's. There's a third thing that could happen.
You can go to 0.
Could be 0 too, right? If it's 0, would I get i's? No. Square root of 0 is what? 0, okay? So this is, here's an opportunity to save yourself lots of time. A lot of times in math and in applications of math and science, we might be looking for just the real answers. And I'll probably give you some problems like this on the next test. where I'm going to say find all the real solutions to this quadratic equation. If no real solutions exist, then enter n or something like that. Right? So wouldn't it be nice if you could avoid having to do all that work? If right away you could tell if you weren't going to get real solutions. Well, you can. When you're doing, let's say, the quadratic formula, where would you probably start with the quadratic formula if you wanted to be able to say, oh,
Inside the bracket.
I can give up. I know I'm not going to get real solutions.
Inside the bracket.
Yeah, we could start with that part, couldn't we? Right? That's where we could start with simplifying, okay? This is a valuable thing. It allows us to discriminate between equations that have real solutions only or imaginary solutions, right? And that's why we call this in math, we give it a name, we call it the discriminant, because it enables us to discriminate between situations where we are going to get real solutions and situations where we're not. So if we let capital D for discriminant, if that equals b squared minus 4ac, if the discriminant is greater than 0, what did you tell me that meant again? Would that mean, did we get any i's? If D is positive, part inside the radical? No, no negative numbers in the radical, no i's. How many solutions are we going to get? How many? I heard 2. A tentative of 2. 2 is correct. How come we're going to get 2?
Oh, plus or minus.
Plus or minus, yeah, because I'm going to get plus or minus. The square root of a positive number is just some number, right? So I'm going to get negative b plus or minus whatever that gives us. Agreed? Okay, so I know I'm going to get 2 real solutions if d is positive, if d is greater than 0. What if d is less than 0? Yeah, I'm going to get 2 imaginary solutions, aren't I? Because I know I'm going to get i's in it, and I'm going to get 1 for the plus and 1 for the minus, right? Okay, what about in between? What if d exactly equals 0? What's the square root of 0?
0.
Okay, so then think about this. On the top of our fraction, we're going to get negative b plus 0 and negative b minus 0. Are those different? They're the same. So what are we going to get, Cheyenne? We're just going to get 1 real solution. Okay? Let's look at this graphically, because this tells us something about the graphs of the functions, and this is part of one of the next assignments you got. Let's look at the first example that we did, this guy. Okay, this takes us back, remember at the start of the year when we did some stuff, we solved equations by graphing, right? And that was a really easy, we could use technology to do it for us, right? We said that if we have some equation up here, we could graph whatever's on the left side of the equation and whatever's on the right side of the equation and just look for where the graphs do what? Intersect. Good. So wherever they intersect, those are going to be the solutions, right? Those are the x values, the x coordinates of the points of intersection are the solutions. So let's do this. I'm going to use Desmos. Okay, so we've got our first equation is just going to be x squared minus 16x, so I'll change this one, plus 73. Okay, and that one's going to be red. So there it is. There's a graph of that function. Y equals 0, what's that going to look like?
The straight line.
No, y
No,
equals 0.
It'd be just a dot on 0.
No. What's the line y equals 0 going to look like?
It's going to be at the origin.
It's going to be, it is going to intersect the origin. Yeah.
Go to it. Not fun.
Okay.
It'd be along the edge.
Have you seen the crash of it?
Uh-huh.
There's a hot in a tree.
Really?
Yeah.
Well, that's not good.
Crazy.
Okay, so y equals 0. Yeah, that's going to be the x-axis, right? So that's the blue graph. Now, if we look at the intersection, Well, what's the intersection there of the red parabola and the x-axis? There isn't one. Okay, so how does that make sense? How does that, how is that consistent with the algebra we did? When we did this problem, we ended up getting solutions that had i's in them. So are those real solutions? No, they were imaginary, right? So if the discriminant is negative and we get two imaginary solutions, what do you think that tells us about x-intercepts? Is the parabola, is the graph going to have any x-intercepts?
No.
No, it won't, right? It won't. Okay, let's look at the other example we did. We took this example right here. Now we have two options with this one, don't we? We could either graph the function 5x squared minus 4x minus 7 and the function x squared and look for the intersections, right? But that's a little bit complicated because those are both going to be parabolas. It's easier and better if we put this into standard form first, where we end up with a 0 on the right side, because the graph of y equals 0 is always just the x-axis, right? So we're just looking for x-intercepts. So let's graph this one, 4x squared minus 4x minus 7, and see if that ever crosses the x-axis. Do you think it will? What were our solutions were what in this case?
Yeah, because it won't because it's.
Well, let's see.
Oh, no, that has no I.
There's no i's, so the discriminant is positive, so what do you think? Is it going to cross the x-axis?
Yeah.
How many times?
Twice.
2, right? 2, because we got two solutions. Okay, let's look and see. Make sure we're right. Oh, wrong thing. Okay, so what did we say? 4x squared. We're graphing the yellow one, right? 4x squared minus 4x minus 7. All right, so we get solutions, sure enough. There they are. Let's look at the values of those x-intercepts. Right, so there's one of them is at, somebody write this down. Robert, write this down for me.
Right.
Negative 0.914 is one solution as a decimal. The other solution where it crosses the x-axis is 1.914.
So it's close to 2.
Okay? So if we go back, what do you think we're going to get if we go back and we find the values of these two solutions? And remember, there's two solutions here. Right? If we want to input these in Moodle, and I've gotten this question quite a bit, if we want to input these in Moodle, I've got to enter the two solutions separately, right? So I've got to write one of them as 1/2 plus square root of 2 and one as 1/2 minus square root of 2. If I put those into my calculator, look what I get for my solutions. 1/2 plus the square root of 2 is, what do you know? 1.914. 1/2 minus the square root of 2 is negative 0.914. Same ones we got from the graph to 3 places, right? Okay. What do you think is going to happen in the case then? We actually had 3 possible outcomes that we looked at. Discriminant's positive gave us 2 real solutions, so 2 x-intercepts. If the discriminant's negative, we got 2 imaginary solutions, no real solutions, right? So that was no x-intercepts. What do you think is going to happen if d equals 0? If the discriminant is 0, what's the graph going to do? It's going to touch the x-axis at one point, isn't it? It's only going to have one x-intercept. What point is that going to be on the parabola, do you suppose? What do we call that point on the parabola? The vertex. It's got to be the vertex, doesn't it? Okay, so let's look at that. So this guy here, let's calculate the discriminant. What's b squared? Yeah, negative 8 squared, right? So that's going to give us 64 minus 4 times 1 times 16. What's that equal to? 64 minus 0, isn't it? 64 minus 64 is 0. So let's just check our logic and see if this works. Okay, what do you know? We've got we've only got one x-intercept, and it's at the vertex, and it's got a value of 4. Okay, does that make sense? Okay, all right. I think you can work. I've got some assignments up. Grab a Chromebook, get going on those.